Now, problems from definite integral. Integral as the limit of a sum. Consider this problem. Integral 0 to 1 e raised to x dx. Integral 0 to 1 e raised to x dx. We know integral a to b of x dx is b minus a into limit n tends to infinity 1 by n into fa plus fa plus h plus fa plus 2h plus etc. plus fa plus n minus 1 h, where a and b are the limits of integration, a being the lower limit and b being the upper limit, and h is the interval length of the interval, which is b minus a divided by n. And now here, this a equal to 0 and b equal to 1, and h is equal to b minus a by n is equal to 1 minus 0 by n is equal to 1 by n. 1 by n. And therefore this is equal to this, the expression is this b minus a into limit n tends to infinity 1 by n into fa plus fa plus h plus fa plus 2h plus etc. plus fa plus n minus 1 h. Or this is equal to b minus a, which is 1 minus 0, 1 into limit n tends to infinity 1 by n into fa equal to 0. So this is equal to f0 plus f0 plus h, so which is fh plus f2h plus f3h plus etc. plus fn minus 1h. And this is equal to limit n tends to infinity 1 by n into f0. Here fx is e raised to x. So fx is e raised to x means f0 is e raised to 0. E raised to 0 is equal to 1. So this is 1 plus fh is e raised to h. So 1 plus e raised to h plus f2h e raised to 2h. So e raised to 2h plus e raised to 3h plus etc. plus e raised to n minus 1h. And this is equal to limit n tends to infinity 1 by n into, consider this terms of this series 1 e raised to h, e raised to 2h, e raised to 3h, etc. e raised to n minus 1h. This is a GP. First term a, common ratio e raised to h. A square e raised to h whole square, ar cube e raised to h whole cube. So this is the sum of a GP with the common ratio r equal to e raised to h. And therefore this sum is a into r raised to n minus 1 by r minus 1. A is 1, so 1 into r raised to n e raised to h whole raised to n minus 1 by e raised to h minus 1. R raised to n minus 1 by r minus 1. So this is equal to this limit n tends to infinity 1 by n into e raised to h whole raised to n. So which is equal to h is equal to 1 by n. So e raised to 1 by n whole raised to n. So which is equal to e raised to 1 by n whole raised to n minus 1 by e raised to 1 by n minus 1. H is equal to 1 by n. So minus 1. And this is again equal to limit n tends to infinity 1 by n into e raised to 1 by n whole raised to n is e raised to 1, which is e. So numerator e minus 1 divided by e raised to 1 by n minus 1. So here we need the expansion of e raised to x. We expand this e raised to 1 by n as an infinity series. So we have the result, this e raised to x equal to 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus etc. to infinity. 1 plus x over 1 plus x by 1 factorial plus x squared by 2 factorial etc. That is, this e raised to x is equal to 1 plus x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial plus etc. to infinity. This is the expansion of e raised to x. So using that, we expand this e raised to x, or which is equal to e raised to 1 by n. So we see that this 1 plus 1 by n by 1 factorial plus 1 by n whole squared by 2 factorial plus 1 by n whole cube by 3 factorial plus etc. Then minus 1, this minus 1, e raised to x minus 1. E raised to 1 by n minus 1, this minus 1. And this is again equal to limit n tends to infinity 1 by n into e minus 1 divided by this plus 1 and this minus 1 get cancelled. So this is equal to this 1 by n plus 1 by n squared into 2 factorial, 1 by n squared 2 factorial plus 1 by n cube into 3 factorial plus etc. to infinity. And now we apply this limits. Applying the limits. So applying the limits, substitute n equal to infinity after multiplying this with this 1 by n. So we see that numerator is e minus 1. So e minus 1 divided by, so this 1 by n, here there is a 1 by n in the denominator. When we multiply this, 1 comes in the numerator and n comes in the denominator. So this becomes this e minus 1 divided by, here n by n comes here in the numerator. So n by n, which is 1 plus 1 plus, here becomes this n in the numerator. So 1 n cancels with the 1 n of this n squared. So there is an n in the denominator into 2 factorial. Since there is an n in the denominator, when we apply this n equal to infinity, n tends to infinity, this term becomes a 0. This term becomes a 0. Similarly, here also there is n squared in the denominator. So this term 1 by this term will become 0. So we see that this comes in the denominator. Plus etc. And hence we see that after this first term, all the terms will involve an n in the denominator. So all the terms will become 0. So we see that this is equal to e minus 1 divided by 1, which is equal to e minus 1. So integral 0 to 1 e raised to x dx is equal to e minus 1. And suppose we apply the first method, fundamental theorem of integral calculus, what happens? If we integrate this e raised to x, we get the result e raised to x. Applying the limit 0 to 1, which is equal to, first apply this 1, e raised to 1 minus e raised to 0, which is equal to e raised to 1 minus 1. Very simple. So the answer is e minus 1, integral 0 to 1, e raised to x dx is equal to e minus 1.